As you can see in the last lesson I told you, maximum powers of tan. Very simple. In sine power and cos power, you split them as 3 and 1. Odd powers, yeah? In tan, whether it is odd or even, tan and cot. Similarly, sec and cosec, split them as a square. Meaning, if you have tan power 5, write as tan squared and tan cubed. If you have cosec power 4, you write as cosec squared and cosec squared. If you have sec power 6, write as sec power 4 and sec squared. Let's take, in other words, split power n as n minus 2 and 2. And then this n minus 2, then I think giving notes becomes a bit of a problem. Then use identities and substitution, as I will show you. That's a general method. Okay. Let's take the first example. Okay. What do you want? Sec, cosec? No, even powers of sec. Sec cube can't be done. No. Sec squared and sec, then you can't do it. It's any power more than 3 for sec. I think cosec power 5, cosec squared, no, it doesn't work. This one, even powers. This is any power more than 1. So integral, let's take sec power 6x dx. So straight away taking a horrible question. I don't think you'll get a question like this. But just showing you the method. Split the power as sec power 4x times sec squared x dx. But why? Why are we doing this? As it is, there is no formula for sec power 6. I can't integrate directly because the derivative of Secx is not a constant. But sec power 4 can be written as sec squared the whole squared. Sec squared can be written as 1 plus tan squared. And in that, when I differentiate tan, I get sec squared. So indirectly, the idea is to get a function and its derivative. So coming back to this, it is integral 1 plus tan squared x the whole squared times sec squared x dx. Now when I differentiate a tan, I get a sec squared. Of course, I will leave it to you to use u equal to tan x and arrive at the answer, which I am going to arrive by inspection. That's integral 1 plus 2 tan x plus tan, 2 tan squared x plus tan power 4x times sec squared x dx. If u is tan x, that is du. Sec squared x dx is du. So it gives me x. No, sec squared x gives you tan x. Okay, let me show you how. Integral sec squared x dx plus 2 integral tan squared x sec squared x dx. You know why I'm doing this way? I'll tell you in a minute. Plus integral tan power 4x sec squared x dx. Why I need not write this. Why am I writing it is? Some of my clever students, even way back when I was teaching in schools, they applied this method, but somehow this one they wrote it as x, whereas it's 1 sec squared. When you integrate sec squared, you get tan, you don't get x. And majority of my students, even the bright ones, wrote an x. That's why I had to split it. So this is tan x plus when I differentiate a tan, I get a sec squared. So it's u squared du. So 2 tan cube x over 3 plus tan power 5x over 5. I can remove 1 over 15 tan x as a common factor. I get 15 plus 10 tan squared x plus 3 tan power 4x plus c. You understand that? And I forgot to turn on the stopwatch as usual. Sometimes I remember, sometimes I forget, which is a bit stupid of me. I think I'll use about 10 minutes on this one. Right? Suppose I had integral cot power 4x, cot power 4, 3x dx. Cot cube, let's make it cot cube. No, cot power 5. Okay. Very good. Split them as? What do we split them as? What do we split them as? N minus 2 and 2. So it is cot cube 3x and cot squared 3x dx. Yeah. And that cot squared is now I can either split cot cube. There's no formula for cot cube, but there's a formula for cot squared. What is cot squared? Cosec squared minus 1. So it is integral cot cube 3x times cosec squared 3x minus 1 dx. So it is integral cot cube 3x cosec squared 3x split into another integral minus integral cot cube 3x dx. The first one, when I differentiate, of course I forgot to write a dx. When I differentiate a cot, I get a cosec squared. So I can use substitution or inspection. But I can't integrate cot cube. Remember when I did the even powers of sine and cos, I made a statement. Repeat the mixture till either the patient dies or the patient is cured. But we maths doctors are very good doctors. We don't allow the patient to die. We aim at only curing. That means I want to get rid of the cot cube. So can I write this as cot cube 3x cosec squared 3x dx. Because I'll use u equal to cot 3x. So that becomes, I can say minus integral cot cube minus 1/3 integral cot cube 3x times minus 3 cosec squared 3x dx. Why? This, when I differentiate cot, I get minus cosec squared. So this is u cube du, u power 4 over 4. So that bit minus 1/3 times cot power 4 3x over 4. That integration is done. Minus, what did I say? The power is more than 1. Write cot cube as power 2 and power 1. So cot 3x, cot squared 3x dx. Repeat the mixture till the patient dies or is cured. So it is minus integral cot 3x times cosec squared 3x minus 1. Let me write it here. I'm just doing that bit because the first one is already done. So it is minus integral cot 3x cosec squared 3x dx plus integral cot 3x dx. When I differentiate cot, I get minus 3 cosec squared. I have a minus, so I'll make it as a plus, and I'll make, or let me write it as 1 over 3 integral cot 3x times minus 3 cosec squared 3x plus, when you integrate cot, I get ln sine. So cot 3x gives you ln sine 3x over 3. This will be 1/3 u du. So u squared over 2. So it will be plus 1/6 cot squared 3x plus 1/3 ln cot 3x plus c. See, the techniques are different. Each one is a different way of doing things. Okay? That was just terrible, wasn't it? Let me take a sine because somehow cot, I'm a tan, because sine and cos, sorry, sec squared and cos. I already did sec power 6. So I will do cosec power 4, but before that, let me do for tan. Integral tan power 4 x dx. Split into 2. So it's integral tan squared 2x times tan squared 2x dx. I cannot integrate tan power 4, I can't integrate tan squared. But I got 2 tan squared. I know tan squared is x squared minus 1. So, but don't use for both, then you end up having a sec power 4. So, whenever you split, if both powers are same even powers, then substitute for only one of them. Look, if this were to be tan power 6, I would have tan power 4. So, and tan squared, I would write tan squared as x squared minus 1. But this is tan power 4, so I've got 2 tan squareds. Change only one of the tan squareds to sec squared. So it's integral tan squared 2x times sec squared 2x minus 1 dx. So that becomes integral tan squared 2x sec squared 2x dx minus integral tan squared 2x dx. Here, when I differentiate, or is it x? Okay, let me change it to 2x because I made it 2x everywhere. Okay, now when I differentiate tan 2x, I get 2 sec squared 2x. So I write it as half integral tan squared 2x times 2 sec squared 2x dx minus, there is no formula for tan squared, but there is a formula for sec squared. So write tan squared. Anytime you see as a tan squared, write it as x squared 2x minus 1 dx. Here, if u is tan 2x, then this whole thing becomes du, u squared du. So half tan cube 2x over 3 minus sec squared 2x gives you tan 2x, 2x gives you 2, plus 1 gives you x plus c. I purposely didn't use that because substitution again, that 1, this and the other way, students will write it as tan x. So to avoid that, I have to do it this way. Okay? Good? That's quite interesting. No, I can't as a teacher exhaust all possible combinations of trig functions. So we do the generally the ones that or common. But there are unusual cases which I'll take up when I do revision on integration, okay? Suddenly, sir, you didn't teach this before? Yeah, I didn't, because I can't. It's humanly impossible to think of every possibility and give you. So sometimes we pick up questions later toward the end to show you, look, this is what I told you, but unfortunately, it doesn't work. Okay. So suppose I have integral tan cube x sec power 4x dx. No, should I take that? No. This is again, I'll have to go into the realms of even and odd and so on. So integral is there anything I can do? Oh yeah, I haven't done cosec. So cosec power 4x 4 3x dx. Split. That's all. So cosec squared 3x times cosec squared 3x dx. Again, remember the sec power 6, I had a sec power 4 and a sec power 2. So it was easy for me. But because the powers were different, so I used the higher power, converted it into tan. Whereas here, I can't. Both are the same. Then change one of them to cot. So integral cosec squared is 1 plus cot squared 3x times cosec squared 3x dx. That's integral cosec squared 3x dx. Please don't try to use substitution there, even though it works. Safer to split them into two integrals. Plus integral cot squared 3x cosec squared 3x dx. Remember, I have put a gap there. What do you get when you differentiate cosec squared? When you integrate cosec squared, you get cot. So it resembles the standard formula. But cosec squared x gives you cot x. I have a 3x. But when I differentiate 3x, I get a 3, which is a constant. So I can integrate directly. Very good. So that's minus cot 3x over 3. Here, when I differentiate a cot 3x, I get a minus 3 cosec squared 3x. I have a cosec squared, I don't have a minus 3. So I'll put a minus 1/3 and put a minus 3. By writing that in the exam, you're telling the examiner you're a genius. You know how to do inspection. Or if you don't like it, please use at this stage u equal to cot 3x. And then work out, you'll get the same answer as I get. So it is minus 1/3 u squared du gives you u cube over 3. So the final answer will be, I can remove minus 1/9 as a common factor. I get 3 cot 3x plus cot cube 3x plus. So I've taken even powers only of cosec or sec and any power greater than 1 of cot and tan. That finishes the standard integrals involving trigonometric functions. But not all. As I said, there are so many others which, in fact, sometimes we use what's called the half angle and the double angle formula, or T formula rather, which is, as far as Edexcel is concerned, it's in further maths, so I'm not going to teach you that now. Right. So I will stop at this stage as usual and then look at the last bit of integration before I go to areas, volumes and then differential equations. That would be integration by parts. Okay. Bye-bye. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded, and launched. Thank you very much.